Industrial factory floors are highly controlled, predictable spaces. Construction sites are the exact opposite. Every day, the physical terrain changes completely, with massive materials and heavy equipment constantly moving through temporary, shifting shapes. Because the environment is inherently unstable, mitigating danger requires a structured, systemic approach. This is the domain of occupational health and safety. Occupational safety prevents sudden physical incidents, like collapses or machinery accidents, before they cause injury. Occupational health targets invisible, long-term damage, neutralizing hazards like silica dust, chemicals, or heat stress. A complete system integrates both, creating a continuous, overlapping barrier for the worker. Because the terrain shifts daily, risk mitigation can never be a static, one-time setup. It requires continuous, active management to match the evolving threat profile of the site. What makes a construction site uniquely hazardous is its reliance on temporary structures, like scaffolding and formwork, placed directly alongside active, heavy earth-moving machinery. You have multiple independent contractors working in the exact same footprint at the exact same time. Plumbers, electricians, and riggers cross paths constantly, creating overlapping zones of danger. This density leads to an acute accident potential. The primary physical threats include falls from extreme heights, electrocution from exposed wiring, and sudden structural collapses. While accidents are immediate, invisible airborne threats often result in more severe long-term attrition than sudden physical impacts. Inhaling silica dust during routine concrete cutting severely damages lung tissue over time. Handling raw construction chemicals without proper ventilation or enduring intense heat stress for 10-hour shifts degrades the human body steadily and quietly. Before a single structural column is poured, keeping a human crew alive and functional in this space is a complex logistical operation. Rigorous OHS standards function as a critical business safeguard, ensuring the project remains viable within a high-threat environment. The complexity of site safety multiplies when we factor in workforce demographics. The first major variable is the heavy reliance on migrant labor. Workers routinely travel across states and regions, converging on a single site in dozens of different intersecting directions. This introduces immense friction. You have multiple language barriers, distinct cultural differences, and a general unfamiliarity with local site conditions and terrain. The second massive variable is contractual employment. Workers are rarely hired directly by the principal employer. They are sourced through layers of independent subcontractors. This fragmented hiring structure results in rapid workforce turnover, inconsistent skill levels across trades, and zero long-term ownership over safety practices from the crew itself. This Venn diagram maps the intersection of these two variables. When you layer the communication friction of a migrant workforce over the fragmented ownership of contractual labor, standard operating procedures break down. Basic safety instructions are lost in translation or actively ignored by a temporary workforce that feels no permanent connection to the site's management. To counteract this elevated threat, administrative systems must adapt. Protocols have to be stripped of complex engineering jargon entirely. They must be simple, highly visual, actively trained, and continuously supervised. Using clear visual indicators and running task-specific repetition through daily toolbox talks bypasses language barriers entirely and resets safety expectations for a transient crew. The invisible management systems must be robustly engineered to bridge the operational gaps created by a fragmented and rotating workforce. To enforce these systems, regulatory frameworks establish strict accountability. The Building and Other Construction Workers Act of 1996 sets the precise baseline for legal compliance. This flowchart illustrates the legal chain of command. The law is clear. The primary burden of identifying site hazards and conducting comprehensive risk assessments falls squarely on the principal employer. Once hazards are mapped, the employer must implement safe work systems. This requires formal administrative controls, like job safety analyses for specific tasks, and strict permit-to-work systems for high-risk operations. The execution of these tasks requires the employer to furnish appropriate personal protective equipment, like helmets, harnesses, and respiratory filters, while guaranteeing that every individual receives task-specific safety training. The legal duty extends to maintaining continuous supervision, running routine compliance audits, operating active emergency rescue plans, and fire protection systems. They are mandated to provide welfare infrastructure, like clean drinking water, proper sanitation facilities, dedicated rest areas, and immediate medical support. A common and fatal error in the industry is the assumption that hiring a subcontractor completely isolates the principal employer from these obligations. That is a legal fiction. Responsibility for worker health and safety cannot be transferred or contracted away. The principal employer remains the ultimate, non-negotiable anchor, ensuring both strict legal compliance and the physical survival of every person on the site. A persistent bias among junior site engineers is the belief that stopping work to enforce safety compliance inherently delays the project schedule. We can test the logic of this assumption with a routine task. Take a worker required to cut heavy steel reinforcement to exact specifications. This timeline charts the outcome. In the unsafe approach, bypassing approved methods saves 10 minutes. But the immediate consequence is physical harm. Work stops entirely to investigate. Secondarily, an improper cut yields a flawed component, guaranteeing scrapped material and a massive schedule delay. Now run this same task using the safe approach, utilizing correct tools, proper gear, and the established job safety analysis. Correct methods ensure physical control. With zero injuries and flawless execution, the task is completed rapidly and accurately. Bypassing safety protocols introduces uncontrolled variables that inevitably degrade the timeline and compromise the project schedule. Enforcing safety is the act of controlling environmental and physical variables before a task ever begins. When work is highly controlled, exact methodological sequencing and strict attention to detail become possible. That level of control directly dictates the quality of the final construction. High quality yields durable structures built correctly the first time. Eliminating structural defects eradicates the financial sinkhole of massive rework, which in turn maximizes output. We visualize this relationship as the core performance engine of the industry, the safety, productivity, and quality triangle. No single element exists in isolation. Safety creates operational control. Control yields pristine quality. Quality drives productivity, which affords resources to maintain rigorous safety. Maintaining this system unlocks cascading financial and reputational advantages. It sharply reduces worker compensation costs, eliminates regulatory penalties, and secures deep trust with high-tier clients who demand a spotless compliance record. Treating health and safety as a competing interest to profitability is a failure of management logic. They are the exact same mechanism. A robust occupational health and safety system is the foundational prerequisite for project viability. It is the only way to transform a chaotic, high-risk construction site into a predictable, highly profitable operation. Construction sites are high-risk environments. Safety protocols typically focus on immediate, kinetic dangers, a fall from scaffolding or a strike from heavy machinery. Occupational hazards encompass both these immediate physical injuries and the long-term illnesses that develop over a career. The core challenge lies in the chronicity paradox. Many high-risk threats remain invisible, causing health problems that go unnoticed until biological damage is severe. This table compares accidents to occupational diseases. First, occurrence. Accidents are sudden. Diseases are gradual. Therefore, visibility changes. Accident effects are immediate. Disease symptoms are delayed. Finally, the cause. Accidents stem from a single event, while diseases result from repeated daily exposure. This delay creates a psychological blind spot. Without early-stage symptoms to act as warning signs, workers and managers frequently ignore the long-term impact of daily exposure for immediate safety concerns. Our intuitive risk assessment fails here. The mechanisms that cause permanent biological damage bypass our immediate perception of danger. We can track this biological damage by examining chemical hazards. These arise from continuous exposure to harmful substances in solid, liquid, or gaseous forms across the site. Routine activities act as the primary generation point for these exposures. Cutting concrete fills the surrounding air with a dense cloud of fine particulate dust. The specific threat hidden inside that cement dust is silica. When airborne, silica forms microscopic, jagged particles that are easily inhaled. This diagram of the human lung illustrates the biological mechanism of silicosis. As silica particles enter the airway, they embed in the alveolar tissue. The lungs respond to this constant irritation by developing rigid scar tissue, which reduces breathing capacity. The condition takes years to manifest, eventually presenting as chronic shortness of breath and chest pain. Once the scarring occurs, silicosis is irreversible, frequently leading to disability or death. The lungs are not the only vulnerable tissue. A second major chemical risk vector comes from direct dermal contact with materials like wet cement, solvents, and industrial adhesives. Cement contains highly alkaline compounds. When wet cement repeatedly comes into contact with the skin, it triggers a harsh chemical reaction. This continuous alkaline exposure strips away the skin's protective moisture barrier, leading to occupational dermatitis. Workers develop chemical burns, deep cracking, and chronic irritation. Chemical hazards are reactive agents that alter and degrade the body's tissue architecture over time. Environmental energy exposures present a similar, gradual threat. We classify these as physical hazards, specifically focusing on intense noise and mechanical vibration. The primary sources of acoustic trauma on any site are loud, constant operations, such as heavy transport vehicles, loud air compressors, and heavy jackhammers. Looking at this schematic of the human inner ear, we can see the impact of high decibel exposure. As sound waves strike the ear, the microscopic hair cells within the cochlea gradually flatten and break apart under the strain. This structural degradation drives noise-induced hearing loss. It often begins with tinnitus, a persistent ringing, and progresses to irreversible deafness that impairs a worker's ability to communicate safely. Mechanical energy poses an equally destructive physical hazard. We categorize vibration risks into two types: hand-arm vibration from tools like drills, and whole-body vibration experienced by heavy machinery operators. Continuous, high-frequency mechanical vibration traumatizes the body's vascular and nervous systems. Years of operating vibrating tools restricts blood circulation and damages nerves in the extremities. Uncontrolled physical energy leads to sensory and nerve loss. Over time, this transforms experienced workers into systemic safety liabilities because their physical awareness has been compromised. Beyond energy and chemicals, we must also account for biological hazards. These are health threats originating from living organisms and unsanitary site conditions. Untreated factors like stagnant water, contaminated soil, and poor waste management serve as breeding grounds. These environments expose workers to bacteria, fungi, and vector-borne diseases that cause serious infections. Finally, we face ergonomic hazards. These injuries result from a physical mismatch between the limitations of the worker's body and the work task design. Construction work constantly requires routine biomechanical stress, repetitive manual lifting of heavy loads, periods of prolonged kneeling, and working in awkward twisting postures. This skeletal schematic shows the physiological toll of these actions. Repeated physical strain forces mechanical loads onto the lumbar spine and knees, degrading joints and soft tissues faster than they can naturally heal. The resulting pathology is a category of injuries known as musculoskeletal disorders, or MSDs. These manifest as chronic stiffness, joint pain, and long-term immobility. Ergonomic hazards cause a cumulative mechanical failure of the human body. They are the leading driver of early, permanent disability in the construction industry. Because occupational diseases lack immediate visibility, safety management models built solely around accident prevention fail to protect workers from chronic damage. To prevent occupational illness, we use the hierarchy of controls, a system designed to neutralize hazards before they interact with human biology. The most effective tier represents engineering controls, which alter the physical environment or equipment to eliminate the hazard at its source. We engineer out risk by deploying mechanized handling aids instead of manual lifting, and using wet cutting methods on saws to suppress silica dust. When a hazard cannot be physically engineered out, we drop down to the secondary tier, administrative controls. Administrative protocols manage risk by manipulating time. Managers use job rotation and exposure limits to prevent workers from accumulating a toxic chronic dose. Only after applying these first two tiers do we reach the final, least effective option, personal protective equipment, or PPE. There is a critical misunderstanding regarding equipment like respirators and earmuffs. PPE is not a preventative safety measure. It is the last possible barrier of defense, deployed only when all other systemic engineering and administrative controls have completely failed. Occupational health relies on moving past behavioral compliance. Safety is an applied engineering problem designed to systematically neutralize invisible threats.